welcome to This Explainer. Okay, today we are tackling something absolutely huge. I'm talking about one of the most mind-bending mysteries out there, demystifying the incredibly elusive concept of time. We all experience it, right? Every single second. Yet penning down exactly what it is has literally puzzled humanity for centuries. So, in This Explainer, we're going to explore a completely fascinating paradigm shift proposed by Juan Carlos Holland de Barcelos, who goes by Jocax, and this framework promises to finally clear things up for us.
Here's our roadmap for how we're going to break this all down today. First, the mystery of time. Second, Newton's classical view. Third, time according to Jocax. Fourth, the function of clocks. And finally, the illusion of simultaneity. Let's get right into it.
All right, Section 1, the mystery of time, defining the undefinable.
Okay, let's dive into this with a question we've all probably asked ourselves. What is time? It's this massive, shared human frustration. We feel it passing, we constantly measure it, we're always rushing against it, but what actually is it? Seriously, think about it for just a second. How would you explain time to someone without using any words related to time itself? You know, words like past, future, or duration. It is way harder than it looks.
Well, if you struggled with that, don't sweat it, because even the dictionary throws its hands up. Just look at this definition from the McCallis Dictionary. It defines time as a measure of duration, an epoch, or a lapse of future or past time. I mean, it's laughably circular, isn't it? It's basically using words entirely dependent on the concept of time to define time itself. It completely fails to tell us what the underlying physical mechanism actually is.
And honestly, it's not just dictionaries that get stuck in that loop. Look at how top-tier science and philosophy handle it. Because it's so difficult to pin down, time is often just brushed off as a psychological event. The great physicist John Wheeler famously joked that time is just nature's way of preventing everything from happening at once. Even Albert Einstein, the guy whose theories literally revolutionized our understanding of the universe, often surrendered to framing time as just a persistent illusion. It's a super convenient way to sequence things, sure, but that still leaves us wondering what time is in a physical, tangible sense.
Which brings us to Section 2, Newton's classical view, the old paradigm. To really appreciate this new Jocaxian paradigm, we first got to look at the old one, championed by Isaac Newton. Newton believed in an absolute, true, and mathematical time that flows equably without relation to anything external. Basically, in his mind, time is this rigid, straight line extending infinitely into the past and the future. He saw it as a giant cosmic clock that just keeps on ticking, completely regardless of what actually happens in the physical universe.
But here's the hard truth. While this absolute Newtonian view feels incredibly natural to how we experience life day to day, it's completely scientifically obsolete. It violates core principles of modern physics like relativity, and even philosophical arguments like the Coulomb theorem. The whole idea of this detached, ever-ticking background clock, it simply doesn't hold up anymore. Time must be intimately connected to the universe itself.
So moving on to Section 3, time according to Jocax, the new paradigm. Okay, here is the absolute game changer, the core revelation of this explainer. Time is simply the quantity of events that occurred in the universe. Just let that sink in for a moment. Time isn't some invisible, flowing river. It is literally a relation between changes of state. It's a raw measurement of actual events. This means, and this is wild, if absolutely nothing changes in the universe, if not a single solitary particle moves or alters its state, time literally stops. Time does not exist independently of action. No action, no time.
And this brilliantly illustrates the massive contrast between these two models. On the left, we've got Newton's time, this independent, continuous flow. It's like a river that just keeps running whether there are fish swimming in it or not. But on the right, we have Jocaxian time. Here, time explicitly requires state changes. It is a discrete, literal count of events. If nothing happens, the counter stops, time freezes. The whole concept of time is 100% dependent on physical changes happening within the cosmos.
Let's break down how this actually works for understanding precedence, how we know one thing happened before another. Imagine a totally blank hypothetical universe where nothing has happened yet. Step 1, event A occurs. Okay, we now have exactly one event logged in the entire universe. Step 2, event B occurs. Now there are 2 events logged. Because the total universal event tally was lower when A happened compared to when B happened, we can definitively say event A precedes event B. Time is simply tracking that master running tally of universal changes of state.
All right, Section 4, the function of clocks, measuring events.
So, if time is just this grand cosmic tally of events, what the heck is your wristwatch actually doing right now? Well, actually, scratch the whole idea of it keeping time. We need to completely reframe how we see clocks. A clock doesn't create time, and it certainly doesn't measure some mystical flowing river. Instead, think of a clock as a highly active micro-universe that we've intentionally designed to constantly change its state. With every single tick-tock, the clock is undergoing a physical change. Now, because it's practically impossible for us to count every single quantum event happening across the entire cosmos, we use the predictable tick-tocks of this micro-universe, our clock, as a localized, manageable proxy for counting universal events.
Which leads us perfectly into Section 5, the illusion of simultaneity, a measurement limit.
So if time is just a discrete sequence of universal events, what does this actually mean for two things happening at the exact same time? To really wrap our heads around simultaneity, we got to look at the sheer precision of our best clocks. Right now, scientists have built atomic clocks using ytterbium atoms that are stable to within 1 part in a quintillion. That is a 1 followed by 18 zeros. It's a visually staggering level of precision. But here's the crazy part. No matter how hard we try to zoom in, a microscopic interval always exists between those ticks.
And that right there is the hard limit of physical reality. According to Heisenberg's uncertainty principle, we can absolutely never achieve infinite clock precision. It's theoretically impossible. This means there will fundamentally always be a tiny gap between the finest ticks of our most precise clocks. And within that minuscule gap, if two events happen, we physically cannot know which event truly occurred first.
This inherent measurement limitation causes a really weird ripple effect that we call the transitivity paradox. Check this out. Imagine event A and event B occur within the exact same microscopic tick of a clock. Since we can't tell them apart, we call them simultaneous. Then event B and event C happen in the very next tick, so they get grouped together too. Now, simple math logic says if A equals B and B equals C, then A should equal C, right? But in this reality, event A and event C are not simultaneous because they fall into entirely different measurement intervals. Perfect simultaneous isn't necessarily transitive. So the crucial point to take away from all this is when we ground this abstract theory in our actual physical universe, exact simultaneity basically doesn't exist. Between any two visible events in our world, there are countless microscopic, universal events happening constantly. I'm talking about the endless creation and annihilation of virtual particles just popping in and out of a vacuum. Because these quantum events act as continuous steps in that grand universal tally, it practically guarantees that no two things ever truly happen at the exact same time. One event is always going to have a slightly different universal event tally than another.
It's a total paradigm shift, isn't it? Time isn't some phantom dimension flowing past us, it is literally the heartbeat of action in the universe itself. Without change, there is no time. So I'm going to leave you with this final provocative thought. Knowing that time is really just a relentless tally of the universe changing its state, how will you view the tick-tock of your watch tomorrow? Are you just going to see an arbitrary measurement of a passing day, or will you see a mechanical micro-universe racing to keep score of the cosmos? Thank you so much for joining me on this explainer. It's been a blast. Until next time, keep questioning everything.